Look at your hand. Right now. These fingers, this skin, the blood pumping through your veins, it's all made of stardust. Carbon, nitrogen, oxygen, forged in the hearts of stars that died billions of years before Earth even existed. You are a walking piece of the universe that became conscious of itself. But what happens when that piece of the universe you've encountered something so massive, so dense, that it doesn't just bend space? It breaks time. I'm talking about a black hole. We've all seen the pictures, the beautiful orange rings, the pitch-black void in the center, but the images lie to you. They make it look peaceful, static. It is not static. A black hole is the most extreme factory of chaos in the cosmos. It's a place where gravity isn't just a force, it's a tyrant. And if you fall into one, the universe outside will quite literally evolve, age, and die before your feet even cross the threshold. Welcome to Black Science. Today, we are not just talking about where you go when you fall into a black hole. We are talking about when you go, because the answer will terrify you. To understand
And it will make you question if you have already
we first
fallen
have to
in.
understand the nature of gravity. In 1915, Albert Einstein published his general theory of relativity, and he destroyed the old way of thinking. He proved that gravity is not a pull. It's not a rope or a magnet. Gravity is a curve. Imagine spacetime as a giant, stretched-out rubber sheet. Perfectly flat. Now, place a marble on it. The sheet bends slightly. That dip is gravity. The marble's mass warps the fabric around it. Now, take that marble away and drop a bowling ball onto the sheet. The dip is much deeper, much steeper. That is what planets do to space. But now, imagine an object so heavy that it doesn't just make a dip. It creates a bottomless pit. A sheer cliff in the fabric of the universe. That is a black hole. To get a black hole, you need to compress an enormous amount of mass into an impossibly small space. Imagine taking the entire mass of our sun. It's huge, right? It's 1,000,000 times bigger than Earth. Now, crush that entire sun into the size of a city, just a few kilometers across. The gravitational pull at the surface becomes so insane that the escape velocity, the speed you need to break free from its grip, exceeds the speed of light. And here's the rule: nothing travels faster than light. So, if light can't get out, nothing can. This boundary, this point of no return, is called the event horizon. It's the skin of the beast, but here is where it gets weird. The event horizon isn't a physical wall. It's a mathematical boundary. If you were to cross it, you wouldn't see a door closing behind you, you would just cross. But for us, watching from a safe distance, your fate is already sealed. Because something terrible happens to your time before you even reach the edge. This is the part that messes with your mind: time dilation. Einstein told us that time is not a universal tick-tock. It is a local experience. Time moves slower in strong gravity. Your head ages faster than your feet because your head is further from Earth's core. This is fact. We've measured it with atomic clocks. But near a black hole, the gravitational field is so catastrophic that the time difference becomes galactic. Let me paint a picture. You are an astronaut. You pilot your ship toward a black hole. I am watching you from Earth with a telescope. As you approach the event horizon, I see your ship slow down. You aren't slowing down from my perspective because of engine trouble. You are slowing down because time itself is slowing down. I see you crawling forward, inch by inch. Your movements become sluggish. Your voice, if I could hear it, would drop to a demonic low frequency. To you, inside the ship, nothing changes. You feel fine. Your clock ticks normally, second by second. But to me, billions of years are passing. As you get closer, I see you start to freeze. You don't stop moving, you just stop in time. On the very edge of the event horizon, you are suspended. The light reflecting off your ship, trying to reach my telescope, is fighting against the black hole's gravity. It stretches out. The light waves become longer and longer. They shift from blue to yellow to red. And finally, they become so weak, so stretched out, that they are invisible to the human eye. You simply fade from my view. I will watch you hover there, frozen, for trillions of years. The sun will die. The Milky Way will collide with Andromeda. The universe will grow old and dark around me, and you will still be frozen on the horizon, just 1 inch away from crossing over. It is the ultimate nightmare. From your perspective, you experience none of that. You just fall right in. But the moment you cross that horizon, the universe outside ceases to exist for you. The cosmic time-stamp of the rest of eternity happens in the blink of an eye for me, but for you, the fall inside has just begun. So, you're inside. You cross the horizon. What happens next? If the black hole is a small one, you won't even have time to realize you're inside. But if it's a supermassive one, like the one in the center of our galaxy, the gravitational pull across your body is disastrous. Your feet are closer to the center of the hole than your head. So, your feet feel much more gravity than your head. The force pulling your feet is so much stronger than the force pulling your head that your body begins to stretch. This is called spaghettification. The gravity doesn't just stretch you like taffy. It pulls you apart, atom by atom. You are a collection of molecules held together by electromagnetic bonds. The gravity of the black hole becomes stronger than those bonds. Your bones break, your ligaments snap, your cells rupture, and eventually, the gravity even overcomes the forces that hold the atoms together. The electrons in your body are ripped from the nuclei. You stop being a person. You stop being a pile of mush. You become a stream of pure, hot plasma, a current of elementary particles screaming toward the center at nearly the speed of light. This stream of particles is falling into the final destination, the singularity. Now, hold on to your seat, because this is where physics gives up. The singularity is a point where space has infinite curvature, and time literally stops existing. General relativity predicts that the mass of the black hole is compressed into an infinitely tiny point with infinite density. But here is the terrifying kicker. We know that's wrong. Physicists know that infinity is not a real number. It's a mathematical error. It means that our understanding of the universe breaks down at this exact point. Quantum mechanics and general relativity can't agree on what happens here. We need a theory of quantum gravity. So, what actually happens to your atoms at the very bottom? There are three horrifying possibilities. Theory number 1, the firewall. Some physicists, like Leonard Susskind, think that the event horizon isn't just a boundary. It's a wall of fire. They argue that quantum entanglement forces the horizon to be incredibly hot. Instead of falling in peacefully, the very moment you touch the horizon, you are incinerated into high-energy radiation. You never even make it to the singularity. You just burn up at the door. Theory number 2, the hologram. This is the weirdest one. It suggests that your body, all the 3D information of you, is actually stored as 2D data on the surface of the event horizon, like a hologram. Inside the hole, you fall to your death, but outside, on the horizon, your data remains. In a way, you exist in two places at once. When the black hole eventually evaporates via Hawking radiation, that information gets spat back out into the universe. You become pure information, scattered across the cosmos. You don't have a body, but your blueprint is immortal. Theory number 3, the white hole. Some physicists believe that black holes are just one side of a coin. The other side is a white hole. While a black hole swallows everything, a white hole spews everything out. If you fall into a black hole, the singularity doesn't destroy you, it ejects you into a new universe. Imagine, you are crushed into a single point, and then bang, you are reborn. You pop out of a white hole in another dimension, another time. But here's the catch. In that new universe, it would look like a big bang. Your atoms would be the very seeds of creation. You wouldn't just fall into a black hole. You would become the beginning of a new universe. We don't know which theory is real. We may never know, because the laws of physics break down at the heart of darkness. But every time you look at the stars, just remember, the atoms inside you, the ones I mentioned at the very beginning, are surviving just fine here on Earth. But out there, in the void, those same atoms are playing a game of infinite possibilities. Your existence is a miracle not just because you are alive, but because you are safe from the abyss, until the day you aren't. If you want to dive deeper into the reality of space, gravity, and time, you're in the right place. Subscribe to Black Science, leave a comment. Which theory terrified you the most? The firewall, the hologram, or the white hole? I read them all. See you on the other side of the void.